Large language models are incredibly powerful, but when it comes to visual reasoning, they often rely on external tools or direct manipulation of image pixels. This presents a fundamental limitation. Models are forced to operate in the high-dimensional pixel space, which lacks abstract representations. Existing methods struggle with scalability and optimizing latent embeddings that capture high-level visual concepts. They're essentially reasoning at a surface level, not grasping the underlying visual semantics. The key idea behind Monet is to enable the model to reason directly in a latent visual space, a lower-dimensional, semantically richer representation of the image. Instead of thinking in pixels, the model generates continuous embeddings, acting as intermediate visual thoughts. These embeddings encode abstract visual concepts, allowing the LLM to reason about relationships and perform complex visual tasks more effectively, similar to how humans use abstract visual thinking. Monet employs a sophisticated three-stage pipeline. First, Stage 1 involves supervised fine-tuning, SFT, using a novel high-quality text-image interleaved chain of thought, COT, dataset, Monet SFT 125K. This SFT pre-trains the model to generate the helpful visual thoughts for reasoning over images. Stage 2 refines the visual thought generation via reinforcement learning with a new objective, VLPO, Visual Latent Policy Optimization. VLPO explicitly incorporates the latent embeddings into the policy gradient updates, encouraging the model to generate embeddings that are both informative and consistent. Stage 3 focuses on instruction tuning using LoRa to align the model's overall behavior with user instructions. Let's dive deeper into VLPO. In standard reinforcement learning, the policy is updated based on rewards received for actions in the environment. VLPO extends this by considering the quality of the latent visual embeddings produced by the model. The reward function is now a combination of task-specific rewards and a term that encourages the model to produce embeddings that are both relevant to the task and semantically meaningful within the latent space. This is achieved by measuring the quality of the generated latent code via visual reward.